mean value theorem for integrals. Objective, by the end of this lesson, you should be able to find the average value of a function over a given interval, understand the graphical representation of the mean value theorem for integrals, apply the mean value theorem for integrals, and last, understand the difference between average value and average rate of change. Okay, so first, let's look at an easy average problem. Find the average for two numbers, 10 and 20. So to find the average for two numbers, what we do is we add those two numbers up, and because there are only two numbers, we divide it by 2, and therefore we get 30 divided by 2, and that gives us 15, and that would be the average for 10 and 20. Now, in general, if we have a finite collection of values from a1 through an, then to find the average or the mean, we use the following formula, which is adding all those values up, and then we divide it by the number of items, which in this case is represented by the letter n. And that gives us an average. Now, if we want to find the average of an infinite collection of numbers, and when we say infinite collection of numbers, we're talking about a continuous function. Specifically, all the values of a continuous function over a particular interval. So how do we do it? For example, suppose the function f represents the temperature as a function of time. Then f is continuous function because the temperature will always change depending on on the time. And we might wish to consider the average temperature over a period of time, right? So you might not know, we don't care about the instantaneous temperature, but what we care about is what's the average temperature for the day, for the morning, for the evening. So how do we do that? Well, to find the average, don't we first find the total temperature for the day? Let's say we want to find the average temperature of that day, so we find the total temperature for the day, and then we divide it by the number of hours. In this case, a day has 24 hours, and therefore you get the average temperature over the 24-hour period. Now, translating that into average temperature mathematically, well, the total temperature can be found by taking the integral from 0 to 24 of this function, and that gives you the total temperature. And then you would divide that by 24 minus 0, which is the amount of time that has passed, and this is a representation of the average temperature over a day or a 24-hour period. So the average value of a function, we discuss about the average value of a function. It is found by taking the total value divided by b over a, or this is another way to write it. Now, I have been writing it in this way, which is the same as that way, so just kind of keep that in mind. So this is the average value, and we have discussed about the average value in a lot of different ways, and we did that over the course of a few lessons. Keep in mind that the average value is also what we refer to as the mean value. Average is mean, so therefore they mean the same. All right, so let's review how to find the average value of a function. So I want you to find the average value of function f. This is function f between 0 and 2. Okay, so average value, first of all, you need to know how to set it up. So here's average value, which is the integral from 0 to 2 of function f over 2 minus 0. That's how we find the average value, right? So we go ahead and we plug in what function f is, and that's just 2. And now we find what this integral equals to. Now, to save some time, actually no, let's find this integral. So to find that integral, we need to find the antiderivative, which is x cubed over 3. And then we will evaluate that at 2 and at 0, and then we'll subtract them. So when we evaluate that at 2, we get 8 over 3. When we evaluate that at 0, we get 0. So when we subtract these, then we get 8 over 3, and then divide that by 2, and that becomes 8 over 6, which is reduced down to 4 over 3. and that would be the average value.